So, hello class. Continuation of our discussion. So, this time, we are dealing with the convergence and divergence of a series. So, it is similar when identifying if your sequence is convergent and divergent. So, we're just getting the limit of our series. Okay? So, the series is convergent if the sequence of partial sum is a convergent sequence. Okay? In other words, there's a limit. Okay? However, the series is divergent if the sequence of partial sums is a divergent sequence. Or in other words, limit does not exist or it is infinite. Okay? So, to give you an example, okay? So we need to evaluate this. Okay, this the summation of 1 over 3 raised to n minus 1 from n equals 1 up to infinity. Okay, so it is similar with the limit as n approaches infinity of 1 over 3 raised to n minus 1. Okay. So by analyzing the behavior, okay, we can analyze the behavior of our series by identifying few terms. Okay, so here's the answer. Now, if we identify the few terms, okay, so we arrive at this answer. So we have our first term. So we have 1 over 1 or simply 1. Second term we have 1/3, 1 9, 1 over 9, 1 over 27, 1 over 243. 1 over 729, so on and so forth. Okay, and if we try to sum this, sum these few terms, it is approximately, or it is approaching 1.5. Okay, if you try to get the summation of this series. Okay, so it is approximately, let me write it here, it is approximately equal to 1.5. So meaning, if there's a partial sum, actually this is a partial sum, right? So this partial sum corresponds to the limit of this series. Okay, so if there's a limit, therefore this series is what? This series is convergent. Okay, so it means in this process, okay, by analyzing first few terms of the series, okay, and yes, get the summation of it. Okay, you can get the limit or the partial sum, and then from that partial sum, if the answer is definite, there's a partial sum, so does its limit. Okay, it is also it corresponds to the limit. Okay, that is also the limit. So whenever the value whatever the value is the partial sum, okay, it is also the limit of this series. And since there is a limit, we can say that the series, our given example here of series, is a convergent. Okay, it is a convergent. Next, so another way of finding the series or finding the limit is basically evaluating the limit. Okay, so let's apply the L'Hopital's rule. Okay, let's differentiate this. Differentiate the numerator and the denominator. Okay, let's start with the numerator. So that is 16, and next differentiate the denominator. So that is 14, and simplify. We just simplify, so cancel this one, so this becomes what? If you simplify this, actually the answer is 8 over 7. By the way, it's negative. I forgot this. It should be negative 14n. Okay. So the answer is this one. Okay. This is the limit. And since there is a limit, therefore, this expression or this series, okay, is convergent. Okay. So, again, identifying if your series is convergent or divergent is similar with identifying if the sequence is convergent and divergent. Okay. So, what method? By knowing the limit or by applying the limit. Okay, evaluating the limit at infinity. Okay, at infinity, at approaches infinity. Okay.